although our environment is responsible for supporting all life on Earth, it turns out that the market for environmental sensing is relatively small. And therefore, the companies that make environmental sensing systems cannot feasibly adopt all the newest technological opportunities into their products. The OPEnS Lab is here to shortcut that system. That is to say, we take the most current cool new sensors and the most cool new microprocessors, bring them together to make environmental solutions to advance the science of environmental sensing. What we do then is we have clients who are scientists who say, we need to have this measurement made. We bring that to diverse, multidisciplinary engineering teams, all undergraduates, who then bring the agricultural, mechanical, electronic, and computer science aspects together and craft a solution using today's technology. We then openly publish those results. So the idea is that we want to take where we are now, which is about a 20-year delay between new technology coming on the market and its inclusion in environmental sensing tools, and bring that down to 2 years. And at the OPEnS Lab, we have 20 projects going on now doing just that. And we think it's an extremely exciting opportunity that motivates students and addresses what we need today in environmental science. The OPEnS Lab came up as a concept really inspired by one of my nephews who built his own 3D printer, and I saw what could happen with that 3D printer and how files could be generated and then shared globally that solved really complex technical issues. I realized, wow, this could change the world. And in the back of a van coming back from an AGU fall meeting from San Francisco to Corvallis, my postdoc and I wrote a proposal saying, hey, let's do this thing. And we really envisioned it having several key components. One was this idea of generalized files that people could ship around and make anywhere they were. And those files might deal with things like circuit boards, 3D prints, and the code to run the whole thing. All that then put up on GitHub, all shared openly, and that's where the name OPEnS really comes to play. It's an openly published environmental sensing laboratory. The other piece of it that was really exciting was having young, emerging engineers really be the mentors for the kind of dinosaurs like me who needed some guidance about how do we do this stuff. And so OPEnS Lab is really run fundamentally by undergraduate engineering students, and they will take in graduate students and other clients and produce those designs needed to resolve the problems brought to them. And so it's this really top to bottom invert model where the young people are the lead and the clients, the old people, are learning from the young. It's worked out really well. We have 20 projects going on right now that span agricultural production to understanding rivers to measuring the DNA of animals in the oceans. And so we've taken on a bunch of different projects, but the overall model is that we do things in such a way that others can reproduce them. Everything is freely shared. It's undergraduate led, and we're always responding to real client needs. And that's the foundation for the OPEnS Lab. Hi, I'm John Selker, and I'm the PI, Principal Investigator of the OPEnS Lab, and I want to talk today about how the OPEnS Lab is related to agriculture. Now, having been brought up first in physics, but then as an agricultural engineer myself, I have tremendous respect for the fact that agriculture is, in my mind, the most complex system that humans are engaged in. It involves climate, it involves soil, it involves nutrients, it involves all sorts of bacteria and rhizomes, and every aspect of nature comes into the agricultural problem. So when we start to talk about making new additions to instrumentation to make agriculture more efficient, it has to come from a lab where people are really aware of what's going on in agriculture. OPEnS Lab has that strong connection to the College of Agriculture at Oregon State University and internationally. And so the solutions we have really deal with what we consider to be the fundamental features of agricultural needs. An example I'd like to share is our dendrometer. So what a dendrometer is something that measures the size of a plant in time. And what happens when a plant is experiencing stress, water stress, it gets smaller. It actually, the suction on that water compresses the stem, and you can see that. And so if you want a measure of the overall state of a plant, measuring it at the stem gives you this overall state of stress. Whereas any point in the soil might be different. The stem gives you an integrated measure. But what happens is during the time that the plant's experiencing stress, the temperature is changing dramatically. And so that means that anything that expands or contracts that's attached to the plant is also being shifted by the temperature. So dendrometers have typically had a lot of problems. Number one, they're temperature sensitive. So when you see a change in their measurement, it may reflect the instrument, not the thing it's measuring. Number two, they use a little plunger to measure displacement. This plunger has friction. So when the plant starts to expand, it takes a while before it starts moving. And when it starts to contract, it takes a while before it starts moving again. And that stiction, we might call it, really causes problems for looking at the subtle changes in a plant stress level. So what the OPEnS lab did is we took a device, a Hall effect sensor, which has no contact. So there's absolutely zero friction. It's accurate to a half a micron, which is better than the current plunger technology. And then we built the entire system out of carbon fiber, which has a zero thermal coefficient of expansion. You put that all together, and you get a dendrometer with performance unlike any other one on the market. Of course, that has to be hooked into a really cool data logging system and a telemetry system. We use LoRa, and the data are beamed right to the farmer or the scientist who's studying. In this case, we're looking at blueberries, we're looking at wine grapes at the moment. Okay, so the point is, the technologies are there, but we have to work from a framework of deep understanding of those agricultural systems in order to address the needs of the growers and the complexity of the system to get the data needed to be successful in advancing agriculture, improving the water use efficiency, for example, creating the right level of stress to get our great wine here in Oregon, and putting it all together into a working package. So the OPEnS lab brings undergraduate engineering students together with clients, and they craft a solution founded on a deep understanding of agricultural systems. Education is going through a lot of changes. And here at the OPEnS lab, the Openly Published Environmental Sensing Lab, we're all run by undergraduate discovery, by making things. And this is really a complement to so much of what's going on in terms of things moving online. What we're doing is keeping things in the people's hands. If we're going to train an engineer, we have to have them make something, typically, where they can actually see what the positives and negatives of their design decisions were, and they can test what they've made and learn from those tests, and then do the iterative processes which are fundamental to engineering. Nothing in the world around us came about perfectly formed of the first generation. It has all been refined and refined. So the OPEnS lab makes a point of, number one, doing the engineering design properly. Number two, doing it where the students are the lead on it. Number three, continuous improvement of all designs. Number four, putting things into production so people actually see what it takes to get something made. All of this is undergraduate led, giving them the hands-on experience to become great engineering designers. It's done with communication, professional communication skills in terms of written, Gantt charts, everything else that's required in a professional engineering environment. And we believe that this hands-on experience, when they're working on something they're very passionate about, is the best way to take engineering concepts and move them into practical, practicing engineering skills. So at the OPEnS lab, we're all about getting our hands dirty, breaking things, fixing them, and learning how to be an engineer by doing it with your own hands. Training undergraduates to become real engineers. It's more than just opening a textbook and getting one more equation under your belt. It really requires getting student hands into the process all the way from the beginning idea to a completed design. That hands-on experience for engineers is exactly what the OPEnS Lab tries to provide for our undergraduate community. We now have 40 undergraduates engaged in this activity, and we develop teams that are diverse with agricultural, mechanical, electrical, and computer science skills in the teams. And they are faced with a problem. They have to develop a solution, and then they have to execute on it and write it up. That process of making it with their own hands and seeing the outcomes of their decisions, and then communicating that professionally to the clients and to the worldwide community, we think is the deepest and most impactful educational experience that a young engineer can have. We really believe in getting our own hands into this, getting the students' hands into this, and having them have a real-world experience where they take it from the concept to completion with their own hands, and they own all the success, and they own all the lessons learned along the way. That's where we see the future of engineering education. In-person experience, doing things with mentors, but basically doing it with your own hands and learning from those trials. And we think that we've learned a lot from the last 2 years of remote teaching, but there's nothing like the opportunities of doing something with your own hands that are real.